Welcome back. Well, I was in my local Dollar Tree here the other day, just picking up some supplies. Don't knock dollar stores. There's certain things you can get in them that are very valuable at $1 even, believe it or not. I don't have any really thing here to show me right now, but there are things, trust me. In fact, I perhaps will do a video on the subject one day. You know, things like sandpaper, paintbrushes. There's little stupid things that you can get there that's on the more disposable level that, hey, for $1 you can't go wrong. Well, anyway, as I'm checking out, I happen to see one of these devices out the corner of my eye. In fact, it was the USB port on the side of it that made me go, what is that? And I see it's an emergency USB charger. This is distributed by Greenbrier International. As you can imagine, that's pretty much the dollar store brand right there. But, you know, it's one of these AA battery power banks, which I thought was pretty neat. Why do I think this is neat? Well, if you know anything about batteries, electricity, voltage, stuff like that, this AA battery is a 1.5 volt battery. When you get two of them put together in series like this, you get 3 volts. Except the thing is that it's USB connector. USB is 5 volts. So there has to be circuitry inside this to boost the 3 volts to 5 volts. And I don't know what the drop off is, you know, because as these 1.5 volt batteries start to die, you obviously won't, you know, get the full voltage out of it. So does this have like a Joule thief setup where you can get the most amount of current out of the battery and voltage? So I'm not sure. And I kind of just want to take it apart. I mean, at $1, even if I mess the thing up and can't get it back together, so what, you know? For the entertainment value, it's sure worth it alone. Also, I'm wondering how hackable this is, because maybe I could take 2 D-cell batteries and hook it to the same circuitry. You'll get the same end result, but it'll have a lot longer of a charge time on it because of the bigger batteries. So there's a couple things I have to think about with this. What I will do is hook up an extension cord, so I'm in camera here, and I'll get my USB charger out for my cell phone, and we'll see how much current the battery draws off the charger, and then we'll do the test off of this battery pack to see how much power it actually does put out. Now I know it's an emergency charger, as it states, and it says that it gives you over an hour of talk time, so it's not going to really draw a lot of from those batteries. There really isn't a lot to draw since they're so small. Now if you had a bunch of AA batteries lying around and you wanted to charge your cell phone off that, I guess it would work. But one thing I'll point out, I'm not a fan of, the battery case just slides right off this easily. There's nothing you have to squeeze, it just comes off. That's kind of not good. But the batteries do seem like they stay in pretty well, which is good. You do have to take the outside one out before you can take the inside one out. I thought there'd be a little LED indicator on here. There isn't. And they came in multiple colors. I mean, just for the size of the thing alone, it's pretty cool. But there are certainly a lot of things you can do with a portable 5 volt battery supply like this that runs off 2 AA's. In fact, you could probably even use your chargeable batteries on this and you get a little bit more bang for your buck. But let me go ahead and get some setup here, and we'll see what we can do about opening this up. Alright, what we have here is a standard cell phone. This is a non-smartphone, so this isn't an Android, it's not an Apple phone, it's just a regular, good old-fashioned cell phone with the slide-out keyboard. We also have the power bank. We have a charge doctor, which shows you the voltage and the amperage coming out of whatever USB device you plug this into. We have an extension cord, so I can plug in my benchtop power supply that I put together and kind of bring everything off onto camera here. And then we have the charger for the phone, which has been slightly hacked. All I did was just cut the end off and then solder the wires onto these headers, connect the end of the charger back onto the board here, just so if I wanted to connect, let's say, an LED or something like that to the circuit, I can go right ahead and do so fairly easily. But we're going to go ahead, plug that in, we're going to get a baseline score here to see what we're getting out of my power supply versus what this little power bank's putting out. So I'll just hook this up real quick. If I plug this in, you'll see on the display 4.92 volts, 9.1, slight fluctuation, and then it's going to go over to amps, which is obviously 0 amps since we have nothing plugged into this. I can unplug that and plug in the power bank. We can see it's 5.25 volts with a little more fluctuation than the other supply had, and again 0 amps because there's no load on it. Now if I go back to the original power supply here, we'll plug that in and we'll connect the battery here, and we see as soon as we connect the phone, it drops down to 4.8 volts. Still maintains stability though. Battery is charging as indicated by the red light, and it's 0.00 amps. I have a funky connection here, it looks like. Yeah, 0.011 amps, which is 111 milliamps. It's a, fairly good draw for something with a battery in it, but not crazy. Certainly not 2 amps or whatever this power supply says it puts out. Yeah, we're at 0.13, and that's happily charging the battery. Now if I disconnect that and plug in the power bank here instead, we can see that the voltage went down from 5 something down to 450, 430, but the amperage, we're putting out a lot of current. We're putting out 0.53, 0.65, that's 650 milliamps. So that's a really good amount of juice that this is putting out. Now what's interesting to me is that this power bank is actually putting out more current than my benchtop power supply is, and that's rated at 2 amps. So it makes me wonder, will this thing actually charge my tablet? We'll have to give that a shot. Also, just for ha-has, I'm gonna unhook that and unhook my extension cord and plug this directly into the power supply and see if that changes anything. And we can see we have that right up here in the corner here. Yeah, actually it looks like it's putting out 0.41 amps, so 410 milliamps. So there's definitely something wrong with the USB extension cord here. It could be that it's a light gauge wire. It could also be that this is a power cable and not an actual extension cable. Some of these phones actually do connect to whatever device they're being connected on through the data connection. Like the tablet I have won't put out the full 2 amps unless the charger knows that there's a demand for it, and it does that through the data connections. Now I know from a personal fact that these power supply I built here doesn't have standby, the data connections. It's just power out. So there's definitely something wrong with this cable, and I'll probably have to just chuck it. But it's still not putting out the same amount of current that this battery pack can. So that's pretty interesting. We'll have to do a little bit more of an investigation on that. And by doing that, I'm going to take my tablet out over here, which is already charging, and we'll give that a shot and see. And right now we're seeing the Samsung charger for my tablet is putting out 0 amps because nothing's hooked to it, and about 5.2 to 4.8 volts depending on where it's fluctuating here. Now I can tell you that the tablet is off right now, and when I plug this in, it's going to tell me how much life's left to charge it. Now as soon as that connects in, my tablet shows that it's starting to charge, and it's putting out 1.5, 1.67 amps. So that's pretty good. That's a good amount of draw. We're at 93% on the tablet too, by the way, left to charge, or 93% charged, I'm sorry. And yeah, we're getting that pretty huge number out of there. Now if I disconnect this and plug in our power bank, will we get the same result? Right away we get that voltage drop. and the voltage is okay, but it's putting out, you know, it was putting out 0.5 amp. Now it's fluctuating here a little bit, and it's a pretty big fluctuation. Now it is charging my tablet though. It's showing the 93% on the screen again, which is pretty cool. So I can actually use this to power my tablet. Now obviously with the big battery in your tablet, you're not going to get a lot of juice out of this thing. So I would recommend this more for cell phones, but if you wanted to charge a tablet, you could certainly do so in a pinch. But again, it's not the full current that it could get out of the actual little charger here. So that is something to note. So let's go ahead and crack this thing open, see what's inside of it. At first glance, there isn't any screw holes, so that kind of makes it a little bit harder, but that was expected. Upon a second investigation, looking around the edges, trying to find a place I could push it in, hopefully pop it off, that doesn't seem to be as promising as I wanted it to be. So then I started thinking maybe this thing is just, you know, welded together through heat or some kind of a plastics method, but I'm not sure. But I did notice in here, which you're not going to make out on camera, but there's these little grooves which indicate that this thing is actually snapped together, because we can find that pinch line. It's just a matter of can it be undone. So I'm going to go ahead and poke and prod around here a little bit. If it has to be destroyed in the name of science, then by golly, we're going to do it. But you know, after all, the thing was $1 anyway. But we're going to get into this thing no matter what. Oh, that wasn't that easy to get into. Yeah, everything was welded, like plastically welded together, which is kind of odd for such a cheap device. But there were some posts in there that were, you know, kind of glued. So I don't know if this will go back together or not. I don't really care. This is something I kind of wanted to just play around with. And that's it. That's the whole shebang right there in that little circuit board. There is a little 3-pin chip on there, so that's probably going to be a transistor. But I will look up the number on here, see if I can find everything. It looks like it's B3P55. There is a diode over here. There's a couple capacitors, and what looks like is a choke or a inductor, and that's fundamentally it. So it makes me wonder, you know, I'll have to do a little research. Now it does say on the board here version 2.0. Let's see if we can get a close up there of that board. And it says 3 volt rise 5 volt. So obviously it's meant to step up 3 volts and bring it up to 5 volt. We can do some experimenting here. I do have a 3 volt source we can play with. And I'm assuming the capacitors are going to pick the actual, you know, voltage that this thing puts out. We'll have to check that out. Also, the diode right over here, that's going to be your input protection most likely, because it is wired in, it looks like. I'll have to check it out. I should actually reverse engineer this using some of the methods I found on YouTube here to see if we can try to figure out the entire circuit. I'm going to go do that real quick. Well, one day leads to another and leads to another, and then you turn around and look at your bench and realize, you still have a project you have to work on here and a video to finish. And here it is Wednesday night, so I want to get this done for Thursday, obviously. So I decided to get this done. Now I went ahead and drew a kind of sloppy drawing here because it wasn't kind of the easiest thing to do, because believe it or not, this is actually a two-sided board. And while it's a not very complicated board, this was giving me a little bit of trouble because there's some traces I couldn't see where they went. A couple went underneath this inductor, and then they come out on the other side via these little vias. And so just trying to figure out which side was which and what went where, and you know, it was a little fun. But anyway, Unfortunately, I couldn't find any information online about that transistor or possible chip. I'm assuming it's a transistor. I don't really know, honestly. And I couldn't find a schematic online either, which is fun. But the number is B3P55, and it turned up no result. The diode did, though. The diode is an SS14. It's a Schottkey barrier rectifier diode. And I guess I could put a, link to a data sheet in the description if you care to see it. Unfortunately, though, the two capacitors, C1 and C2, are unmarked. I have no idea what they are, nor do I have a component tester to tell me what their values are. The inductor, which again I'm assuming is an inductor, it looks like an inductor, I don't know what the value of that is. And another thing that's weird is all these parts on the board are labeled V minus, V plus, D1, C1, C2. The chip is marked as U1, but there's no markings on the actual inductor, which is kind of neat and odd at the same time. I'm not sure why they went that route. And of course there's just a little heat shrink on here, so I can't really see what it is. I mean, I guess if I really wanted to, I can pick up another one of these and, of course, hack the little circuit board out of it, maybe desolder the stuff out of it, for my own personal knowledge. I will tell you, though, I did Google the 3-volt rise 5-volt wording on here and found similar circuits that they're selling on good old eBay for $7 with shipping per module. For $7 you could pick up 7 of these things at the dollar store and extract them and have little mini 3-volt to 5-volt power converters here. So I intend on building a little project box and stuffing this in there with a couple D-cell batteries, because they'll certainly last a lot longer than the 9-volt, or sorry, for the AA batteries will, and would be a little bit more of a versatile thing. Now I'm pretty sure the input voltage is going to directly relate to the output voltage based upon the components here. So if you drive a heavier load into this, two 1.5 volt batteries is 3 volt. If I use my 3.3 volt bench supply here, I'm going to get more than 5 volts out of this end. Pretty sure. So that's one thing to consider. You're not going to want to drive too much into this. I mean, in comparison, here's a converter. I've done a video on this separately. This is a buck converter, I guess you could say, where you can get a variety of input voltages, and the circuitry in here is going to buck the current down, the voltage I should say. But this has got a lot more components. There's ICs on here, there's more diodes, more pretty much everything, a big inductor, some big capacitors, and obviously the little LED screen on here is a whole different thing on its own. But this wasn't a whole lot of money, but it certainly wasn't $1. And I know they both have their own application. At the end of the day, I'd probably feel safer using this unit, but it's going to operate on a lot different voltage range than just 3 volts. But I digress. But anyway, you can see from my little drawing here that the V plus input looks like it goes directly to the capacitor, which also goes directly to the V minus. So that's probably some kind of a smoothing capacitor of some sort, just to suck in some of the I don't know what the proper way to say that is. It's probably it's taking up some of the current or the voltage, or it's doing something here just to smoothing everything out. That goes into the inductor, then that goes up into one of the legs of the transistor. That same line also goes to the diode, which goes up to another capacitor and goes to the case of the USB jack, which is also the ground, or the V minus rail, we'll call it. Also back to that diode, the center pin and the outer pin here, which it's probably used in some kind of like heat dissipation. That's why it's soldered on that way. They're actually common. I used my meter and put it on continuity mode, and I got continuity out of both of those. So I just you know, for the sake of showing that, I just drew this little line over here and jumped it over to that middle connector, but you know, they're on the same plane. You can actually see, if I get a little closer up here maybe, that this is on this back plane, and you know, you could even see on the other side that it's all one piece. And then the last leg of that is the middle leg, and that middle leg goes directly to the positive of the USB jack over here. The two middle ones are the data plus, data minus connection. They're just jumped directly out in the middle. Not sure if that works or not. I have to look at other jacks and see. I didn't think shorting out the data connections was a good idea, but evidently that's what they did here. And we could also see that the V minus, that negative rail, that's connected also to the case, and it's also connected to that other leg. So I guess one's a base and one's a emitter, one's a collector. Honestly, you know, I'm good with the simple stuff. When you start getting into transistors and ICs, and it's a little beyond my scope of knowledge to be able to explain the right way to explain it. I guess that makes sense. I'm learning this. This is all a learning process. I'm good with the diodes and the capacitors and resistors, and you know, I built plenty of kits in my lifetime, but those are more like put part A into part A slot, put part B in the part B slot. I don't know why you picked these particular values for capacitors here. You know, I'm assuming that's what dictates what voltage you're getting out of it somehow along the lines here, but I don't really know, honestly. So this is a learning process, and this is how you learn. You got to mess up so you can learn, and hopefully there's somebody watching this video who's more in tune with this and can explain how exactly this particular circuit's working. But you know, at the end of the day, I know the two AA batteries are giving me 5 volts, and it's intriguing how it does that with such little, you know, little component count, and that now that we have this extracted, we can make something else for it. And that's the main gist of it. What do I have? Basic idea how it works, and what can I do with it now that I have that knowledge? And the theory of why they use those components, and you know, is this actually a transistor? Is it not a 3-pin or 4-pin chip and just a different layout? I don't really know. And it's too bad I can't find more data on it. And I'm sure if I keep looking I will, but you know, it was a really interesting thing for $1 to pick up. And what else can I say? Except thanks for watching. As always, you know, I do enjoy making these videos. I enjoy getting the comments on them, even when they're not always positive comments, because you know, sometimes you have to have those negative comments to solidify the good ones, or make the good ones feel better at least. Fortunately, I haven't been getting too many negative comments, which is great. I do get a lot of positive feedback though. People asking questions or telling me, you know, their idea of how things work or whatever, and I love that. So please put those down in the description, in the comment section below, and don't forget to give me the thumbs up or thumbs down. Hey, you know, you have that option. And if you're not a subscriber, please do so. And once again, thanks for watching, guys.